Hello classmates, in this lesson, we will learn the prerequisite content of ultrasonic testing of welds. That is, the welding process of the weldment, the form of the welded joint, the form of the groove, and the common defects in the weld. Many metal structures are manufactured by welding. For example, the well-known bird's nest gymnasium in China started construction on December 24, 2003 and was completed in March 2008 with a total cost of 2.267 billion yuan. As a national landmark building, the main stadium of the 2008 Olympic Games, the National Stadium was very significant structural characteristics. The stadium is a super sports building and a large stadium. The main structure is designed to have a service life of 100 years. The fire resistance level is level 1. The seismic fortification intensity is 8 degrees and the underground engineering waterproof level is level 1. The welding seam quality control of all its steel structures is carried out by ultrasonic testing. At present, the most commonly used method for inspecting the internal quality of welds are radiographic testing and ultrasonic testing. For dangerous defects in welds, cracks, and incomplete penetration, especially microcracks and slight incomplete penetration, are easier to find with ultrasonic testing and radiographic testing. Compared with radiographic testing, it also has the advantages of portable equipment, fast detection speed, and low cost. Features: in order to select testing conditions reasonably and make a correct judgment on the testing results, the testing personnel are required to know the relevant welding knowledge. Welding is a processing method in which two separate materials are atomically bonded by heating or pressure or both, with or without filler material. The welding process includes fusion welding and pressure welding, and the main object of ultrasonic testing is fusion welding seam. The fusion welding process is actually a smelting and casting process. First, electric energy or other forms of energy are used to generate high temperature to melt the metal to form a molten pool. Together, commonly used welding methods include electrode arc welding, submerged arc welding, gas-shielded welding, electroslack welding, plasma arc welding, laser welding, and electronic beam welding. Among them, electrode arc welding is a welding method in which an arc is generated between the electrode and the base metal, and the higher temperature of the arc melts the electrode and part of the base metal to connect the base metal. Electrode arc welding seam is the main object of ultrasonic testing. Welding joints mainly have several forms, such as butt joint, corner joint, lap joint, and T-joint, as shown in the figure. Butt joint refers to the splicing of the center line or edge line of the two parts section on the line, commonly used in plate welding. Lap joint joints are commonly used in fillet welding of sheet metal. T-joints are commonly used in fillet welding of assembled parts. Fillet joint refers to the center line of two parts at 90 degrees. Splicing commonly used in corner welding of box-shaped parts. In order to ensure that the two basement metals can be completely fused after welding, the base metal at the joint should be processed into a certain shape before welding. This processed shape is called a groove form. According to the different material thickness and quality requirements, the welding groove forms are divided into K-type, V-type, I-type, U-type, X-type, etc. When ultrasonically testing welds, the weld joints that are mainly tested include the weld zone and the heat-affected zone. Defects of welded joints include external defects and internal defects. The main purpose of ultrasonic testing is to detect internal defects in welded joints. Internal defects mainly include pores, lack of penetration, lack of fusion, as well as slag, inclusion, and cracks. The porosity is a cavity formed by absorbing excess gas or gas generated by metallurgical reaction when the melting point is high temporary during the welding process and remaining in the weld metal before cooling and solidification. The main reasons for the generation of pores are that the electrode of flux is not dried before welding, and the surface of the weldment is not cleaned properly. Most of the pores are spherical or elliptical, and the pores are divided into two single pores, chain pores and dense pores. Incomplete penetration refers to the phenomena that the metal of the welded joint is not fully penetrated. The reasons for the lack of penetration are that the welding current is too small, the speed of the strip is too fast, or the welding specification is not appropriate. Incomplete penetration is divided into complete penetration at the root, incomplete penetration in the middle, and incomplete penetration between layers. Unfused mainly refers to the lack of fusion between the filler metal and the base metal, or the lack of fusion between the filler metal layers. The main reasons for lack of the fusion are not the groove is not clean, the speed of the strip is too fast, the welding current is too small, and the angle of the welding rod is improper. Unfused is divided into unfused groove and unfused between the layers. Slag inclusion refers to the slag or non-metallic inclusions remaining in the weld metal after welding. The reason for the slag inclusion is that the welding current is too small, the speed is too fast, and the cleaning is not clean, so that the slag or non-metallic inclusion cannot float in time. Slag inclusion are divided into point and strip. Cracks refer to the local cracks in the heat-affected zone of the weld or base metal during or after welding. According to the causes of cracks, it is divided into hot cracks, cold cracks, and reheat cracks. Hot cracks are produced during welding due to improper welding process. Cold cracks are caused by too high welding stress, too high hydrogen content in the electrode flux or too large difference in the rigidity of the weldment. Cold cracks often occur after the weldment is cooled to a certain temperature, so it is also called delayed cracking. Reheated cracks are generally cracks caused by reheating of weldments after welding. According to the distribution of cracks, it can also be divided into cracks in the weld zone and cracks in the heat-affected zone. According to the orientation of cracks, it may be divided in longitudinal cracks and transverse cracks. Please pay attention to distinguish longitudinal cracks and transverse cracks in the direction of the weld. In this lesson, we learned the welding process and common defects of welded joints. When we are familiar with the defect type and the direction of the defect, we can choose the appropriate detection method and correctly identify the defect signal during ultrasonic inspection. That's it for this lesson. Goodbye, students.